guys, today our topic of discussion is forces in nature. There are four kinds of forces in nature which are operative in nature. Thus, it is also known as operative forces. These forces are named as gravitational forces, weak forces, electromagnetic forces, and nuclear forces. Then, our first topic is gravitational force. It is the force of attraction between two objects due to their masses and is governed by Newton's law of gravitation. The force of attraction between two objects of masses m1 and m2 are held at a distance r apart is given by force is equal to g. m1 is mass of one object, m2 is mass of two object, and r square is the distance between two objects, and g is the gravitational force. So where g is equal to 6.66 into 10 the power minus 11 Newton meter square kilogram inverse is called in universal constant of gravitation. The gravitational forces has the following properties. They obey inverse square law. It always attractive in nature. It is long range order, means it's extend up to infinity. The gravitation is the field particle of gravitational force. It is a central force and hence called conservative in nature. Then our next topic is the of forces. Next kind of force is weak force. The weak forces are those forces which comes into play radioactive decay like alpha, beta and gamma and splits up into two or more nuclei. During weak interaction or forces, the two particles are in contact or exactly overlap each other. The weak forces are of the following properties. The weak forces are of short range forces. Its power is 10 the power minus 15 meter. The weak forces are about 10 the power 25 times stronger than gravitational forces. In a weak interaction, neutrino acts as a field particle. The leptons are a class of elementary particles and include electrons, muons, and neutrons and their antiparticles. The weak forces accounts for interaction between leptons and another lepton, between lepton and meson, and between a lepton and a baryon. For example, the process of beta decay is due to weak interaction. The beta decay, a neutron inside the nucleus changes into proton by emitting an electron and uncharged particle which is known as antineutrino. The beta decay is represented as below. It's a neutron, H1 is proton, electron and antineutrino. Then we will discuss about the electromagnetic forces. The electric and magnetic forces are the two facets of electromagnetic force. The force between two static at rest electric charge is governed by Coulomb's law of electrostatics. The electrostatic force between two electric charges held at a distance r apart in a vacuum is given by F is force is equal to 1 over 4 pi psi naught q1. It's represented by q1. It's the symbol of charge. It's q2. It's the symbol of charge present on a atom 2 or a particle 2. r2 is the distance between two particles, where psi naught is 8.854 is equal to 10 the power minus 12 Coulomb square Newton minus 1 Newton inverse meter inverse square is called absolute permittivity of a free space. It is the E naught, it's absolute permittivity of a free space. When a comb is run, it's example of this electromagnetic forces. When a comb is run through dry hair, it it gets charged As such, it can attract small pieces of paper. When we take nylon clothes from our body, sometimes a crackling sound is produced. In dark, even tiny flashes of light can may be observed. It happens because of electrostatic forces that arises between the static charges which develop due to the friction. A static electrical charge does not produce magnetic field. However, an electric charge in motion produces magnetic field. Therefore, when two electric charges are in motion, both produces magnetic field around them. Then each charge moving inside the magnetic field produced by other experience a force called electromagnetic force. The electromagnetic forces are of following properties. It obeys Emerson's square law. Inverse square law. It may attractive or repulsive in nature. It is long range order. The photon is the field particle of electromagnetic force. It is about 10 to the power 36 times stronger than the gravitational force. It is also the central force as well as conservative force. So, what is nuclear force? It is also known as strong force. The forces which are operating inside the nucleus are known as nuclear force or strong forces. In general, the forces that forces these are that forces which are responsible for interaction between masons, between between two masons, between baryons, between masons and its baryons are called nuclear forces. The pi masons, pi naught, pi plus, pi minus, are the field particles for the nuclear forces. The particles the potential energy of the nucleus is found to be of such a nature that nuclear forces are partially central and partially non-central. The nuclear force between the nucleons exists only when they are inside the nucleus. Hence, it is a short range order. It is of the following properties. It varies inversely with some higher power of science. It is basically attractive force. It is short range order force. It is operative only when over the size of nucleus approximately is equal to 10 the power 15 meter. And the pi masons is its field particle. It is the strongest force operating in nature. It is about 10 the power 38 times stronger than gravitational force and 100 times stronger than the electromagnetic force. It is a non-central force. Hope you like, share and subscribe my channel. Thank you for watching this video.